In this video, we are going to talk about simplifying trig expressions. And so we're going to talk about a few strategies that would help us simplify trig expressions. In this beginning part, it does talk about how when we're talking about the Pythagorean trig identities, we need to keep in mind that we could rearrange them. So if I have sine squared plus cosine squared equals 1, if I subtracted cosine squared to the other side, I would end up with sine squared is equal to 1 minus cosine squared. Same with if I subtracted sine squared to the other side, I would end up with cosine squared equals 1 minus sine squared. So just like we have to be able to recognize the trig identities in terms of the Pythagorean trig identities, we also have to be able to recognize the rearrangement of those Pythagorean trig identities. So one strategy we're going to talk about first is rewriting everything in terms of sine and cosine. And so this involves a lot of understanding our reciprocal identities as well as our quotient identities. So in this first example, I have tangent over secant. So if I was going to simplify this by using the strategy of rewriting things in terms of sine and cosine, I would rewrite tangent as sine x over cosine x, and I would rewrite secant as 1 over cosine of x. Now I have a fraction divided by a fraction, so I'm going to do the top fraction multiplied by the reciprocal of the bottom fraction. My cosines are going to simplify, and so I'll be left with sine over 1, which is just sine, which will be the fully simplified form. So let's talk a little bit about the approach. So the first thing we did was we rewrote tangent in terms of sine over cosine and secant in terms of 1 over cosine. Then when we divide fractions, you're going to multiply by the reciprocal. And then we reduced and simplified those cosines. Squared. Another strategy is by using factoring. So in this example, I can see that both of my terms have a cosine. So cosine of x is going to be my GPS. And when I factor out a cosine of x, I'm going to be left with 1 minus sine squared of x. Now, 1 minus sine squared is going to come from the Pythagorean identity cosine squared plus sine squared is equal to 1. So cosine squared is going to equal 1 minus sine squared. So I'm going to substitute that in. And then if I have cosine times cosine squared, I'm going to end up with cosine cubed. All right, so what did we do? First, we factored out a common factor of cosine. Then we use the identity that we know that cosine squared is equal to 1 minus sine squared. And then we multiplied cosine and cosine squared together. The third strategy is getting a common denominator. Well, at first when you look at this problem, you don't see what it means by getting a common denominator because there is no denominator. So actually the prerequisite step to this is I'm going to rewrite in terms of sine and cosine. And then I'm going to see that I need a common denominator. So I'm going to have sine of x plus cosine of x times cotangent is cosine of x over sine of x. So I'm going to end up with sine of x plus cosine squared of x over sine of x. So I'm going to get a common denominator. This sine is over 1. So I'm going to multiply this by sine over sine. So I'll end up with sine squared over sine plus cosine squared over sine, which is going to end up being sine squared plus cosine squared all over sine. Well, sine squared plus cosine squared is 1. 1 over sine is cosecant squared. Cosecant. All right, so let's talk about our steps. So first we wrote cotangent in terms of cosine over sine. Then we got a common denominator of sine for the two fractions. Then we use that we know that sine squared plus cosine squared equals 1. And then we know that cosecant is equal to 1 over sine. All right, the last one is, instead of getting a common denominator, now we're going to split the fraction. So if I have a denominator of secant, I can write that as the denominator of two fractions. And so I'm going to get 1 minus cosine x over secant of x. Now, I'm going to rewrite secant of x in terms of 1 over cosine of x. So this is going to become 1 minus cosine squared of x, because I'm going to multiply by the reciprocal. And 1 minus cosine squared is sine squared. So first we use the property that if I have a plus b over c, I can rewrite it as a over c plus b over c. And then I know that secant divided by secant is 1. I also know that secant is 1 over cosine. And so that means cosine over secant is actually equal to cosine squared. And then the last thing was I know 1 minus cosine squared is sine squared. All right, so let's use some of these strategies now and identify some of these trig functions that we've been talking about. So 1 minus cosine squared, well, I know that's sine squared, so that's going to be option E. Cosine over sine is cotangent, which is option K. Tangent times cotangent, well, tangent times cotangent is tangent times 1 over tangent, which would give me 1. Cosecant times tangent, well, cosecant is 1 over sine, and tangent is sine over cosine. So I'm going to end up with 1 over cosine, which is secant. And so G would be the answer for 4. 5 is a little bit trickier. So I have sine squared times 1 over cosine times 1 over sine. So I'm going to simplify this sine with one of these sines. So I'm going to end up with sine over cosine, which is going to give me tangent, which is option A. In number 6, we have 1 over cotangent squared. Well, 1 over cotangent is tangent, so 1 over cotangent squared is going to be tangent squared, which is option C. In number 7, we're going to have to FOIL this. So I'm going to do 1 times 1, 1 times negative sine, sine times 1, and sine times negative sine. And so my middle terms are going to subtract, so I'm going to end up with 1 minus sine squared, which is cosine squared, and cosine squared is option D. 1 plus tangent squared is secant squared. That's a Pythagorean identity, so that's option F. In 9, I have tangent over secant, so I'm going to use the strategy of turning this into sine and cosine. Then I'm going to multiply by the reciprocal of the denominator, and I'll be left with sine, which is option H. In 10, cosecant squared minus 1. Well, I know that 1 plus cotangent squared is cosecant squared. So if I minus this 1 to the other side, cosecant squared minus 1 would be cotangent, which would be J. In 11, I have sine squared plus cosine squared. I know they're not next to each other, but we can rearrange addition. So sine squared plus cosine squared is equal to 1. So I'm going to have 1 plus tangent squared all over secant. Now 1 plus tangent squared is secant squared, so secant squared over secant would just be secant, which is option G. Yeah, G. And then this is one of our cofunction identities, and sine, when you do 90 or pi over 2 minus x, is the same as cosine of x. So J is going to be 12 is going to be option I. All right, let's use some of these strategies now to simplify these trig expressions. So in this first one, I have sine of theta minus sine of theta times cosine squared theta. So I see that both of my terms have a sine of theta, so I'm going to factor out a sine of theta, meaning I'm going to divide out a sine of theta from each term. So I'm going to have 1 minus cosine squared left in my parentheses. So now, how can I simplify this further? Well, 1 minus cosine squared comes from the trig identity of sine squared plus cosine squared equaling 1. If I minus the cosine to the other side, I end up with 1 minus cosine squared is equal to sine squared. So I'm going to have sine of theta times sine squared of theta, which is going to be cosine cubed. Sorry, cosine to the third theta, or cosine cubed theta. Oh my gosh, not cosine cubed, sine cubed, sorry. All right, in number 2, I have 1 plus tangent squared, and 1 plus tangent squared is a trig identity. It's equal to secant squared. So my top is going to become secant squared, my bottom is going to stay cosecant squared. Now to simplify this, I'm going to turn my top and my bottom in terms of sine and cosine. Then I'm going to have 1 over cosine squared times sine squared over 1, which would be sine squared over cosine squared, which is tangent squared. In number 3, I have cosine of x plus tangent of x times sine of x. So I'm going to try by turning tangent into terms of sine and cosine of sine over cosine, because then I can combine the second term into sine squared over cosine. And then I want to get a common denominator. So since this is cosine over 1, I'm going to multiply by cosine over cosine to get that common denominator of cosine. So I'm going to end up with cosine squared over cosine plus sine squared over cosine. And that's going to give me cosine squared plus sine squared all over cosine. Well, cosine squared plus sine squared is 1, because again, that's that trig identity, it's up here. So we're going to have 1 over cosine, which is secant. In number 4, we're going to have to use factoring. And my numerator is actually a difference of perfect squares, which we haven't looked at in a while. But if I thought about this as pretty much y to the 4th minus x to the 4th, this would factor as y squared minus x squared and y squared plus x squared. So we're going to use that same format. So we have sine squared minus cosine squared times sine squared plus cosine squared, all over sine squared minus cosine squared. Now I can simplify this because my sine squared minus cosine squared and my sine squared minus cosine squared will simplify. My sine squared plus cosine squared will also simplify and become 1 because of, again, my identity that's up here. So this whole thing is just going to simplify to 1. In number 5, I'm going to use kind of the splitting method. So I'm going to say secant of theta over secant minus cosine theta over secant. So I'm going to have 1 minus cosine theta over 1 minus cosine of theta. So when we multiply by that reciprocal, I'm going to end up getting 1 minus cosine squared, which is sine squared. Oh, I accidentally turned it from thetas to x's. Sorry, these should be thetas. All right, in number 6, these kind of look like our Pythagorean identities, but again, they have to be squared to be a Pythagorean identity, so we can't use our Pythagorean identities for number 6. What I can do is kind of work on condensing, so I'm going to leave my top alone for right now. In the bottom, I'm going to change cotangent into 1 over tangent, and I'm going to focus on getting a common denominator just in the denominator. So I'm going to multiply this first fraction by tangent over tangent. So again, I'm going to leave my top alone. In my bottom, I'm going to have tangent over tangent plus 1 over tangent, and so that'll combine to have a common denominator. Again, my numerator is going to stay the same, but in my denominator, I'm going to have tangent of x plus 1 all over tangent of x. Now, since I have a whole number divided by a fraction, I'm going to flip and multiply by the reciprocal. So I'm going to have 1 plus tangent of x times tangent of x over tangent of x plus 1. Since I have 1 plus tangent of x here and 1 plus tangent of x here, those will simplify. So this will simplify to just tangent of x. In number 7, I see I have cosecant and cotangent, and I know that those come from an identity. So if I think about it, if I have 1 plus cotangent squared is cosecant squared. Well, if I minus my cotangent to the other side, then 1 is going to be equal to cosecant squared minus cotangent squared. And that's what I have in my numerator here. So I'm going to end up with 1 over cosine of x times tangent of x. Well, I'm going to simplify tangent of x to sine of x over cosine of x. And so I'm going to end up with 1 over sine of x, which is cosecant of x. All right, our last one, this is a cofunction identity. So this is just equal to cosine of x and then times secant of x. Well, cosine of x times secant of x is cosine times 1 over cosine, which would give me 1.